Our group is doing trigonometric ratios in right triangles, and this is by Antonio Mayorga and Angel Gutierrez. Now, before we get into our real-life example, we want to explain a little bit about the history. Trigonometry now is usually taught beginning with plane triangles. Its origins lie in the world of astronomy and spherical triangles. Before the 16th century, however, astronomy was based on the notion that the Earth stood at the center of a series of nested spheres. To calculate the positions of the stars and planets, one needed to use the concepts we now refer to as trigonometry. Babylonian and Greek influences mingled with rich native mathematical developments in India around AD 500 to produce a trigonometry closer to its modern form. Hindu mathematical works such as that of Aryabhata gave tables of half chords known by the term Jya-Ardha, or simply Jya, which bears the following relationship to our modern concept of sine: Jya(x) equals r sine of x. Another set of trigonometric functions, tangent and cotangent, developed from the study of lengths of shadows cast by objects of various heights. Thales and Miletus used shadow lengths to calculate the height of the pyramids in around 600 BC. Both Indian and Arabic mathematics developed a trigonometric tradition based on shadow lengths, a tradition that, in turn, influenced European mathematics. And that concludes our little history lesson on trigonometry. And now finally, we're going to get into our concept of trigonometric ratios. The ratio of the side opposite theta and hypotenuse is known as sine. The ratio of the side adjacent theta and the hypotenuse is known as cosine. The ratio of the side opposite theta and the side adjacent theta is known as tangent. Now we are looking at the trigonometric ratios. We can see the words, sine, cosine, tangent. We can see the symbol, the definition, and lastly how it would look on a real right triangle. And lastly, we're going to take a look at our shortcut. Remember, the shortcut to remember trigonometric ratios are SOHCAHTOA. So for sine, meaning opposite over hypotenuse, cosine, meaning adjacent over hypotenuse, and lastly tangent, opposite over adjacent. These are the key shortcuts to remember when you're trying to solve a problem like this. And now finally, we're going to get into our real life example. Hope you enjoyed. One day, a man named Angel Gutierrez was walking down the street. He had just come from Miss Padilla's class and was wondering how he could use trigonometry to help his life. Then he came upon this handsome, young, sexy tree. He started looking at it. He had to touch it. He had to touch it more. Then he decided to hug it. And he kept hugging it and hugging it. Then he realized, I want to solve a problem. Angel came upon some tools that could help him in solving a real-life trigonometry problem. He decided that first he was going to measure the tree so he can get started with a problem. He climbed up the ladder and measured the first part of the tree with all the leaves. He had some trouble measuring it, but he got the job done. Then he needed to measure to the floor. Angel was super excited that he was going to solve a trigonometry problem. He measured the tree at 9 feet. He decided to measure 20 steps. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Angel put his measuring tape down and was ready to measure how many steps he had taken in feet. He then decided to take out the measuring tape and measure how much steps he had taken in feet. From this he started pondering, I want to know how many feet it is from the end of my 20 steps to the top of the tree. Angel kept pulling the measuring tape and was super excited to get on with this trigonometric problem. The distance at the end of his 20 footsteps ended up being 17 feet. Angel then looked down and tried to calculate the angle from here to the top of the tree.